The technology of the 1980s, cutting edge as it was for its time, could only scratch the surface of Uranus's secrets. Voyager 2's quick flyby, limited by its trajectory and the capabilities of its sensors, painted a picture of Uranus as a world of stillness. Astronomers saw a planet with little to no atmospheric activity, a place seemingly devoid of the storms and churning interiors that make planets like Jupiter so dynamic. The prevailing assumption became clear: Uranus was the quietest of the giants, a static ice ball, serene and unchanging. But science, like the universe it seeks to understand, never stands still. In the decades since, our tools have become exponentially more powerful. Space agencies like NASA and ESA have unleashed a new era of telescopes and data analysis techniques, epitomized by the James Webb Space Telescope, whose infrared eyes can peer through layers of cloud and haze, revealing the hidden workings of distant worlds. With this new arsenal, scientists returned to the Voyager 2 data, testing its findings against modern observations and simulations. And what they found has rewritten the story of Uranus in profound ways. Far from being a planetary wallflower, Uranus may be hiding a vast internal ocean beneath its frigid stratosphere, a churning electrical sea that could be the missing link in explaining the planet's bizarre magnetic field. This ocean, trapped beneath the icy surface, could be conducting electricity, twisting the field into its off-kilter orientation and suggesting that Uranus is far more active internally than we ever imagined. The possibility of such an ocean isn't just a minor revision. It's a seismic shift in how we view this distant world. Suddenly, Uranus transforms from a static body to a planet of dynamic processes. Subsurface reactions, driven by trapped heat and strange chemistry, could be taking place deep below the clouds. These processes might even connect Uranus to a broader family of icy worlds, planets and moons across the solar system that may also harbor hidden oceans, potentially even the ingredients for life. As our telescopic vision sharpens, new questions arise. What else have we misunderstood about Uranus? Could its bland exterior be concealing storms and activity we've only just begun to glimpse? Every new observation chips away at old assumptions, reminding us that the universe is always more complex, more surprising, and more alive than we once believed. The story of Uranus is now one of revelation and humility. Those first images from Voyager 2 were only the prologue. Our model of Uranus as a quiet, uneventful world is dissolving, replaced by a vision of a planet full of energy and hidden phenomena. Its tilted axis, erratic magnetism, and possible internal ocean mark Uranus as one of the most unique and intriguing objects in our solar neighborhood. And as we continue to probe its mysteries, Uranus stands as a testament to the ever-evolving nature of science, a reminder that every answer leads to new questions and that the cosmos still holds countless secrets waiting for us to uncover them. When Voyager 2 swept past Uranus in January 1986, it brought with it a wave of anticipation and curiosity. No other spacecraft had ever visited this distant world before. A small, silvery disk in the telescope's eye became a real place, a smooth, pale blue orb lurking in the dark reaches of our solar system. The images sent back were extraordinary for their time, revealing a planet with a featureless, almost ghostly atmosphere, a slew of faint rings, and a family of moons. For the first time, humanity glimpsed the true face of Uranus. Yet, as groundbreaking as those first images were, the technology of the era placed significant limits on what could be discovered. Voyager 2's instruments, though cutting edge in the 1970s and 80s, were not designed to probe beneath Uranus's cloud tops or detect subtle atmospheric dynamics. The flyby, lasting a mere 6 hours, captured fleeting snapshots, just enough to ignite decades of speculation. The early interpretation was simple. Uranus was cold, bland, and uneventful. Its surface appeared serene, with little evidence of weather systems or internal heat. The planet's most remarkable feature seemed to be its axial tilt. an extraordinary 98 degrees, causing it to spin almost on its side. Its magnetic field was unlike any other, lopsided and wildly misaligned with the planet's rotational axis. For years, textbooks described Uranus as a quiet, frozen giant in the outer solar system. But science is a living process. With each advance in observational technology, the portrait of Uranus began to shift. The arrival of new telescopes, both on the ground and in space, sparked a re-examination of Voyager 2's data. Astronomers began to notice inconsistencies between what was expected and what was observed. The magnetic field, once considered an oddity, started to hint at deeper mysteries. Its erratic behavior could not be explained by a simple, solid core. Something dynamic was happening beneath the clouds. Enter the era of the James Webb Space Telescope and powerful computational models. These tools allowed scientists to peer deeper into Uranus than ever before. With sensitive infrared observations, JWST could detect faint heat signatures and trace the movements of gases in the upper atmosphere. Supercomputers simulated the planet's interior, testing scenarios for how its magnetic field could be generated. What they uncovered challenged decades of assumptions. The biggest revelation, beneath the icy mantle of Uranus, there may be a vast hidden ocean. This internal sea, rich in water and ammonia, could stretch thousands of kilometers beneath the clouds. If true, it would mean Uranus is far more active than previously thought. The ocean's movement could generate the strange magnetic field, twisting and churning in ways unfamiliar compared to the more straightforward fields of Earth or Jupiter. And this would not be a placid pool. It might be a turbulent dynamic layer, mixing heat and chemicals in the darkness. This discovery turns the old view of Uranus upside down. Instead of an inert ball of gas, we now see a world where unseen forces are at work. The implications ripple outward. Such an ocean could offer clues to the planet's formation and evolution, and even bring into question how many other ice giants throughout the galaxy might hide similar internal seas. The very definition of a planetary ocean has been stretched to cosmic proportions. Other findings have challenged Voyager-era beliefs. Atmospheric monitoring, using both space and ground-based observatories, has revealed that Uranus is not as meteorologically quiet as once thought. There are hints of storms, cloud bands, and even seasonal changes, though all are muted by the planet's extreme cold and tilted perspective. The rings, once thought to be simple and sparse, are now known to be complex and dynamic, shaped by the gravitational dance of Uranus's moons. Each new observation is a reminder that first impressions can be deceiving. The limited data from Voyager 2 was a starting point, not a final answer. Today's astronomers must constantly reevaluate, using better tools and bolder theories to peel away the layers of uncertainty. But this story isn't just about Uranus. The lessons learned here illuminate the broader challenge of planetary science. For decades, models built from brief encounters and incomplete data have shaped our understanding of distant worlds. Now, with new telescopes and interplanetary probes on the horizon, we are poised to rewrite many of these old assumptions. If Uranus can surprise us after 40 years, what secrets might Neptune or even the exoplanets orbiting distant stars still hold? Voyager 2's brief visit is now viewed as the opening chapter in a much grander narrative. The next generation of missions, robotic orbiters, atmospheric probes, and perhaps landers, promise to reveal Uranus in stunning new detail. Engineers and scientists are already designing instruments capable of drilling into the mysteries of its atmosphere, mapping its magnetic field, and searching for seismic echoes from within. Each new mission will build on the legacy of Voyager, transforming fleeting glimpses into comprehensive understanding. The journey to unravel Uranus's secrets is a testament to the power of perseverance and curiosity. What began as a 6-hour flyby has evolved into a decades-long quest, propelled by the relentless march of technology and the human drive to explore. As the story of Uranus continues to unfold, It stands as a vivid reminder that in the cosmos, nothing is ever as simple as it first appears. The more we learn, the more wondrous and mysterious the universe becomes. As we stand at the threshold of a new era in planetary science, Uranus reminds us that even the most unassuming worlds can harbor astonishing complexities. For decades, Voyager 2's brief encounter shaped our understanding of this ice giant, painting a picture of a planet that seemed frozen in time, featureless, calm, and inert. But with each new technological leap, that portrait has been redrawn, pixel by pixel, until an entirely different world has emerged. Recent advancements in space-based observatories, especially the James Webb Space Telescope, have revealed whispers of activity deep beneath Uranus's atmosphere. Infrared observations have suggested that, contrary to long-held beliefs, there may be subtle weather patterns and mysterious heat signatures emanating from within. These findings point to the existence of a possible internal ocean concealed beneath the frigid layers of hydrogen, helium, and methane. This hidden ocean could be the key to understanding Uranus's wild magnetic field, which dances unpredictably compared to any other planet in our solar system. And it's the magnetic field that continues to confound scientists. Unlike Earth or Jupiter, Uranus's magnetic axis is drastically misaligned with its rotational axis, and it doesn't even pass through the planet's center. Instead, it seems to tumble and wobble, a cosmic enigma that hints at dynamic processes deep within the planet, processes that Voyager 2 could never have detected in its fleeting visit. Now, with more sophisticated models and high-resolution data, planetary scientists are beginning to simulate what might be happening beneath those clouds. Perhaps layers of water and ammonia conduct electricity, generating a field both powerful and perplexing. This realization has forced the scientific community to revisit old assumptions. The idea of Uranus as a dormant, lifeless world has given way to a vision of a planet brimming with unseen activity. The possibility of subsurface oceans, internal heating, and complex magnetic interactions suggests that Uranus might even share characteristics with its more tumultuous neighbor, Neptune, or with moons like Europa and Enceladus, where subsurface oceans are considered possible habitats for life. But the story of Uranus isn't just about one planet. It's a window into the workings of ice giants across the galaxy. Up to now, Uranus and Neptune have remained largely unexplored, even as astronomers discover hundreds of exoplanets in distant star systems that resemble these very worlds. The secrets locked within Uranus could help us decode the behavior, composition, and potential habitability of countless other planets beyond our solar system. To truly unlock these mysteries, scientists are calling for new missions, dedicated orbiters equipped with next-generation instruments capable of probing Uranus's atmosphere, mapping its magnetic field in detail, and perhaps even deploying atmospheric probes into its clouds. Such missions could answer questions that have lingered since Voyager 2's 6-hour sprint past the planet. They could confirm the existence of a hidden ocean. They could reveal cyclones, auroras, or even seasonal changes in the atmosphere. Every discovery would bring us closer to understanding not just Uranus, but the broader tapestry of planetary evolution. The journey from Voyager 2's grainy images to today's intricate models is a testament to the power of human ingenuity and the unending quest for knowledge. It proves that even when we think we know a planet, the universe can surprise us. Uranus, once dismissed as a bland, featureless sphere, has become a symbol of cosmic humility, a reminder that our first impressions are only the beginning. As new telescopes are launched and fresh missions are planned, the mysteries of Uranus stand as an open invitation to explore, to discover, and to challenge everything we think we know about our solar system. Each unanswered question is not a dead end, but a signpost pointing the way to new horizons. Thank you for joining us on this journey through the enigmas of Uranus. If you enjoyed unraveling these cosmic secrets with us, make sure to like this video and subscribe for more content like this. The universe is vast, and our journey of discovery is only just beginning. Just beginning.